This is part 2 in our video series where we are determining the oxidation state or the oxidation number of elements in compounds or elements in chemical formulas. So there is a first video where I talked about the rules for determining oxidation states, and we did one practice problem looking at the oxidation state of copper in various situations. We're going to do 3 more elements today. Just practice problems for this whole video. So make sure you've seen part 1 for some context, and let's practice determining the oxidation states of elements in compounds. Now we are going to determine the oxidation number of oxygen in water, H2O, in oxygen gas, O2, in copper 2 oxide, CuO, and in sodium hydroxide, NaOH. If you'd like to try this out on your own, pause the video now. Otherwise, I'm going to start going over the solutions in just a moment. So for number 1, in this neutral compound, 2 hydrogen atoms are bonded to 1 oxygen atom. H2O, water, is a covalently bonded compound. It is a molecule. It is not an ion. So we don't usually think about assigning oxidation numbers in the same way that we think about assigning ion charges, but that doesn't mean that these compounds don't still have oxidation states. So I have 2 hydrogens and I have 1 oxygen. My only possible oxidation state for oxygen is -2. So that's going to go ahead and tell me pretty much right away what my oxidation state is for oxygen. It's -2. It's the only possible oxidation state for oxygen. And so for each of my hydrogens, I must have, there's 2 of them. The overall compound of water is electrically neutral. So each of the hydrogens must have a charge of +1. So the oxidation number of oxygen was -2. Now for number 2, O2. Now, I know I just said a bunch of times the only possible oxidation number of oxygen is -2, but don't forget, if oxygen's just bonded to another oxygen, like O2, O3, that's going to have an oxidation number of 0 because an element bonded to itself has an oxidation number of 0. Copper 2 oxide, let's think about this. Again, the only possible oxidation number of oxygen when it's bonded to a different element is -2. I don't even really have to do any other work. Same thing for NaOH, for sodium hydroxide. The only possible oxidation state of oxygen is -2. See if you can try this on your own now. Determine the oxidation number of hydrogen in the following compounds. Pause the video if you need more time. Let's start with number 1, H2O. So in a neutral compound, there are 2 hydrogens bonded to 1 oxygen. Let's go ahead, since hydrogen has 2 possible oxidation states, let's think about what's happening with oxygen. Oxygen only has 1 possible oxidation state. That's really useful. So I know oxygen's oxidation state has to be -2. That means the only way for my 2 hydrogens to each be able to cancel out or neutralize the -2 charge, they each must have a charge of +1. Let's look at our next question. We've got hydrogen gas, hydrogen bonded to itself, should have an oxidation number of 0 because it's not bonded to another element. H2 means hydrogen bonded to hydrogen. Let's look at NaH. This should have an oxidation number of -1 on the hydrogen. I know this because sodium, Na, has only 1 possible oxidation state, +1. For this overall compound to be neutral, that means hydrogen must have an oxidation state of -1. And then number 4, sodium hydroxide, NaOH. In this neutral compound, 1 hydrogen is bonded to 1 sodium and 1 oxygen. So I'm going to go ahead and think about oxygen and sodium. Each of them only have 1 possible oxidation state, +1 and -2, which means hydrogen must have a +1 oxidation number because 1 + 1 is 2, -2 is 0. That gets us to our neutral compound. In this next example, I want us to determine the oxidation number or the oxidation state of sulfur in these various compounds. Pause the video if you would like more time than is given on the timer. I've also included table E in case you would like to remind yourself about what any of these polyatomic ions mean. So sulfur has 3 possible oxidation states, -2, +4, and +6. Which oxidation state it has in a compound depends on the other elements in the compound and how they're interacting with sulfur in terms of electron sharing. So let's look at hydrogen sulfide, H2S, first. In this neutral compound, 2 hydrogen atoms are bonded to 1 sulfur atom, 1 S atom. So I have 2 hydrogen atoms and I have 1 S atom. I must have positive 1 charged hydrogen atoms in this case. I can figure that out a couple different ways. Sulfur has a higher electronegativity than hydrogen, so sulfur should be doing the reducing if I'm thinking about it in that way. I could also just notice that if I tried to give hydrogen a -1 charge, there would be no way to get this compound neutral, because if there were 2 -1 charges on hydrogen, I wouldn't have any option to have sulfur have a charge of +2 to balance it out. So the only possible way to create a neutral compound with the given combinations of oxidation numbers between sulfur and hydrogen was if there were 2 hydrogens with a +1 state and 1 sulfur with a -2 state. So in number 1, sulfur has an oxidation state of -2. Number 2, sodium sulfate, Na2SO4. So in this example, in this neutral compound, 1 sulfur is bonded to 2 sodiums and 4 oxygens. Another way to think about it is that 1 sulfate ion, polyatomic ion, is bonded to 2 sodium ions. We know that sulfate is a polyatomic ion with an overall charge of -2. So we could also think about it this way. But I'm actually going to just lay out every single atom in this compound. So Na, there's 2 of them, 1 sulfur, 4 oxygens. Let's start with oxygen and sodium because they only have 1 possible oxidation state. So they're pretty straightforward to fill in numbers for, right? Sodium has to be +1 and each oxygen has to be -2. Now, if I add those numbers up, that means my total oxidation number from sodium is +2, my total oxidation from oxygen is -8. In order to get +2 and -8 to come to 0, I would need to have a charge of +6 on sulfur, or an oxidation state of +6 on sulfur. So number 2, sulfur has an oxidation state of +6, and we figured that out by kind of using process of elimination, working through the other elements in the compound. For number 3, calcium sulfate, in this neutral compound, 1 sulfur is bonded to 1 calcium and 3 oxygens. Sulfite is a polyatomic ion with a charge of -2, so calcium sulfite. If I said sulfate earlier, that was an error. Calcium sulfite would still have oxidation states of -2 on oxygen, just like it did with sodium sulfate, but this time calcium is our other element in the compound. And calcium has an oxidation state of +2. There's no other options, only +2. So that means that I have a -6 oxidation state for my oxygen. So I must have a charge on sulfur, an oxidation number on sulfur in this particular compound of +4 in order to balance out the -6 charges from oxygen. 2 + 4 is 6, and that would give me +6 to kind of balance it out. Finally, the oxidation number of sulfur in S2, disulfide gas, would be 0, because remember, sulfur bonded to itself would have an oxidation number of 0. It's quite a bit of work, isn't it? Especially with those elements that have multiple oxidation states on the periodic table to really kind of deduce what the oxidation state must be in a given situation. Just always remember that rule about elements that are not bonded to any other elements having an oxidation state of 0. And keep doing practice problems if you're still confused. This can take some getting used to, but it's important because now we can really look. We've looked at half reactions and figured out if it was oxidation or reduction. We've determined oxidation states. Now we can look at a full reaction that is written as just a regular chemical reaction, not as a redox reaction split into half reactions. And we can actually analyze and think about which compound or which element is being oxidized and which is being reduced, which is going to be really useful as we move into more complex redox reaction topics. Way to go.